Okay, today I only see Migray, Kiara, and who is the Zoom user? You do not post your name, I cannot give you the credit, right? So, who is the Zoom user? Please show your face or change your name, okay? You can go to the participation and click on the Zoom user and click on three dots there. Rename. Click on rename. So I will know who you are. Okay, let me share. Let's share. Can you see the screen? The participant. Migrate. Can you see?
You showing the screen? I can't see if you're showing it.
Kiara, can you see the right-hand side that shows the Zoom user?
Is it on your screen or mine?
My screen.
Oh no, I don't see it on your screen.
Yeah, it just says Zoom user, so I don't know who that is.
Oh, yeah. It's a Zoom user, right? So I don't
Mm-hmm.
know who is this. So how can I give the participation credit or the 10 points? Because I don't know who is this. So please, if you are one of the students in the class, you need at least 10 points. Please change it to your name. Just need a change. Click on the three dots there and click on rename and put your name. Okay. Anyway, we have Yvette join us now. And okay. So today, what we are going to do, I will help you in chapter 12. Okay. The linear regression and correlation. And that's an important tool as well and very useful. So anyone already studied your homework chapter 12? Not
No.
yet.
I mean,
Not yet. How about chapter 11? You done? Or you
yeah,
are working on that?
I did chapter 11, yeah.
Oh, okay, good.
I just have to start chapter 12. It
Yeah,
takes
that's good. So
it
it's right
takes me
time.
a long time to do each chapter, so I am
Yeah.
always a half a week behind everyone else because I
That's
have
okay. That's okay.
to.
As long as you could catch up and submit it and do something, you're okay.
Yeah, so
Because this week it's still okay to do your chapter 11. Okay. Chapter
yeah,
11, chapter 12. Because
yeah,
I canceled chapter 10.
10.
Eliminate. So that's give you more time to learn the 11 and 12. Um, so chapter 12 is talking about how we compare two variables, okay, two sets of the data, and we want to find out their relationship. And their relation can form a straight line relationship or not. That's why we also say linear correlation. Okay, actually should have linear in the front, not just correlation. Linear correlation, because for our elementary statistic, we only focus on straight line first, and later on, when you need a higher level of the statistic, that way you can learn something more. But for now, just a straight line linear correlation. And so far we just do two variables. But in the future, if you know one, for now, you will be able to do for the multiple linear regression, more variables, okay? And because when you do the more, we are going to use computer software. Computer software got capacity for us to do that. And if you transfer to the 4-year university, and if your class require multiple linear multiple regression there. The instructor will show you the lab and how you log on to your computer software, and it's very easy to catch up. So the beginning is hard, right? Usually it's more challenging. So we will start this beginning work first, the foundation. So chapter 12 is for that purpose. We give you some basic concept first. And later you can read the section chapter. There's a section, there's some more explanations. But for our 1 hour meeting only, I will summarize something important part and using an example, right? And plus using our technology, TI 8384 calculator to help you to finish this chapter. Because I remember 20, 30 years ago when I started teaching statistics, was time consuming because at that time we didn't have technology and everything we had to calculate by hand. And whole class after we did so long hour of the computation for just one problem. Only how many people got right? Maybe 1 or 2, okay? Most of the students cannot get right because it's too much of the computations and very easy to make a mistake on one of the steps there with the decimals. So first, maybe I should introduce you some concept because it look like no one finished chapter 12 yet. So the good starting, we should go to our textbook, okay? So I will go to the textbook. Maybe I should click on the textbook. Open stats, right? Open stats. And I already opened something here. Okay. And after I opened, I will share with you. So let me go to open it first. And for you, you can open it in your end too. Just click on the syllabus, this link to go to our textbook and searching for chapter 12, linear equations. Chapter 12 studied the introduction of the linear equations to tell us that this is application from algebra. Okay, algebra we did some linear equations. Usually appears in the algebra 2 or intermediate algebra chapter 3. Okay, and let me share now. Share the book. So you know what I'm talking about here. Or you can open from your side, your laptop computer there. So you can see y equal a plus bs. That's the application we are going to do, okay? And that's kind of slope-intercept form we learned in algebra class, okay? There's no x behind. That's we call y-intercept. I hope this way call your memory back. And then you say plus b times the x. That b is some number attached with a variable x. That usually stands for slope. Okay, so that's the application from the straight line we defined using the algebra way. And there's some example here. You can see like y equals 3 plus 2x. So the 3 is a y-intercept. Is where the straight line will cut our y-axis, the vertical line. And 2 times the x, that's 2, is a slope. That shows the line will go up from the left, go to the right, go up. Okay, positive slope. And what else? And for the real world application, we often will have the number like this. The second example here, like y equal negative 0.01 with decimals, okay, plus 1.2 with decimals. And so we just have to deal with, because real world situation is not always a whole number or the integers only. Most of the time, it's come with some decimals. Then there's some example to show you straight line. Remind your memory from the high school straight line. Look like this, okay? And the point, we cut the y-axis. That's what we call y-intercept, okay? Usually, it's the first number. There's no x behind. And then the steepness of the straight line, that's what we can read from the number attached with the variable x. That's what we call slope. Okay. So this one is trying to remind you what we learned from the algebra class, and we are going to apply to here, okay, in statistic. And you can see this example here is not a straight line, it's curved. So in this class, we are not, we don't care about the curved, okay? That's too early to deal with that. And about the y-intercept and the linear equation in algebra, we learn these three types. The line going up, slope positive, or the vertical horizontal line, no change. Okay, this stands for no change for the real world application. And this one from the left to the right is going downward. That slope should be negative. Okay, so that's the three types we are going to deal with in statistical here. Going up, no change, horizontal line, or going downward. Okay, and going up, the line going up, slope positive, stands for something, two variable x and y, they have positive correlation. When increase the x, we increase the y, okay? And the second case is no change. X doesn't matter what kind of x we have. The y maintain the same number, okay? So when we use this one for the business, that means that the business is not making the money at all. We maintain the same way, okay? And if the business, their profit equation shows like this, the example C, that's not good. The business is going downward, decline, decrease, right? So that's the application we'll be using, okay? Just get some idea from the algebra. Then let's go to the next section. The next section is to try to show you we also can use a graph to learn about this, okay? And the graph, just doing this only, okay? Just put the point, plot the point. So we already done this one in algebra class, okay? So it's nothing new to you, but maybe you forgot because so long we left the high school. And you can see this example only with a simple example, right? Some researcher collected data from vocabulary size of the children as a function of the age. So age is they did the research for the 3 year, 4 years old, 6 and 7. And vocabulary size they collected. 3 years old can talk the number of the words up to the 655. And like the age of the 7 already increased to the 3,195 words. That's the data we have. 2 sets of the data, 2 variables. So chapter 12 is working on this, okay? You must have 2 sets of data. Then we try to come to find out their association. What's their relation here? If age increase, our vocabulary size increase or not, okay? And first thing, analysis, we have to learn how to plot the point. That's what we call scatter plot, because the graph, it shows the point scatter around, okay? And the first point you can see is from the age 3, then vocabulary size is 655. So you look at the horizontal line showing the X chart age at 3 go up. This blue point here is corresponding to the left-hand side at the y-axis for the vocabulary size here, from 500 to 3,500 we have here. So we look at the data. At the age of the 3, vocabulary size only 655. So this point is presenting that situation. Age 3, corresponding left-hand side, the size is about 655 here, okay? And you can observe the second point, age of the 4 is 1,000 words already, more than 1,000, a little bit more. So you look at this point, age of the 4, go to the left-hand side, more than 1,000 words, okay, the position of the point. So that's how we plot all these points. Full set of the full pair of the data here, it should have 4 points here. That's what we call scatter plot, okay? So section 2 is only talk about that, okay? That's why if you have a PI 8384, actually you have instruction on the textbook here, but it show you step by step how you do it, okay? Then 12.3, next section, we need to find a regression equation. That means based on this data we have given here, and after you plot the point, this is real data. You can see this point came out this way, okay? Not all the points stay on the same direction on the straight line. Like this point here is kind of off of the majority, right? But we have to observe the overall pattern. Are this group of the points moving upward or not? Okay. If they're moving upward, that's good. That's we have positive correlation going up. Okay. And we will try to imagine and determine some line. We go among all these points here to represent the direction of this point here. So we try to present what's the movement of this point here in group going up, but based on positive direction, because we can see left-hand side, the point is lower. Right-hand side, the point is higher. It really shows something going up, okay? And we want to estimate, actually we try to approximate, get some estimated straight line. We go among all the points and to capture most of the point. That's what we wanted to do. Majority, okay? So we have process to find out on a straight line. That's what we call linear, we call least square fit method to find out a straight line. Another straight line will come out something like this, one line, okay? Not all the points on the line, but we try to find out the line. We go among all the points with the shortest distance as possible. And that's we need to use the algebra skill to do it, right? A little bit higher level math. But for our class, we don't need to worry for that, okay? We just use we have formula to do it. We just apply the formula, algebra formula. Or today, we have technology. It's even easier now, okay? Because 20, 30 years ago, we have to use the algebra formula. It's really consuming all the time to get done one problem. But now, you are lucky generation, you can use technology to get done very quick and easy, okay? And answer is correct. So the application explanation is on your book there. You should take a look and read it, okay? The process, we need to find the sum of the square errors. And there's a formula. This is a traditional algebra formula. To find out the y-intercept, we have to do y bar minus b times the x bar. And to find out the b, just a slope, you have to plug in this formula. And this formula, you have to do it without work. This is just a formula only, okay? If you have 4 pair of the data, you have to do 4 times of this. If we have 12 pair of data, you have to do this one 12 times. The sum of the x minus x bar for each pair of the x and y, okay? So it's a lot of work for computation. But then this already become the past because our class allow you to use technology. You're not going to use this algebra formula to do it, okay? But I just introduce you. That's how it came from, and that's how the concept it is, okay? So our goal is to try to find this linear regression equation, okay? This straight line go among all the points we have, that the actual data give to us the position of each point here. And you can see they are not exactly on this black line here, but we can see very close, okay? There's one point, there's at least a 1 or 2 or 3 points, 5 points very close to the line and moving upward, okay? Because sometimes our points like that, it moves around, okay? That's why we call scatter plot, okay? And what we do is apply this square criteria for best fit, okay? And using the algebra formula, we'll be able to find out this equation on the line. That's notation. Y hat is estimated y is based on y-intercept negative 173.51 plus the slope 4.83 times the x, okay? And this graphing calculator TI-8384 in case you forgot what we do today here. You can go back to this book here, section 12.3. We show you step by step, okay? So one more thing I want to show you is this. This is the original algebra formula just to find the linear regression correlation coefficient. What's their relationship between x and y and between the two things we observe here, right? And we find out their relation through this coefficient we call R. R is presenting their relationship, how close they are. And this is the formula. This is the one I said 20, 30 years ago, 40 years ago. We had to do this. Okay. When I was in school, I had to do this. Okay. Then after I started teaching, I had to teach this because at that time we didn't have technology. We didn't have graphing calculator, TI-8384. We didn't have computer software to do this at all. Everything do by hand. And you can see so how much is suffering to finish this. Okay. Then there's an important concept here. By the way, can you see my screen? I'm showing the textbook with you. Or you can open your textbook to see there on the section 12.3. Are you, Margaret? Can you see it? Okay, thank you. So this important concept I want to share with you is this. That R is your homework, your exam test will ask you to find out this R, okay, all the time. And this R is a linear correlationship coefficient. This number should be between the two numbers, -1 and 1. If your number came out greater than the 1 or smaller than the -1, you should know you did something wrong, okay? Another thing is if you are close to the 0, that means no linear correlation, okay? If your answer come out the negative, don't be afraid. That's fine. That just shows our correlation is go downward. Slope is negative. That means that when we increase the x, but decrease the y, okay? Their relation is inverse relation. That's why we give you the negative. But if the number close to the 0, that means very weak correlation here, okay? And when R equal to 1, that's the perfect positive correlation. When R came out the -1, that's perfect, 100% correlated. It's like our example from the algebra example. All the points on the line, that's either +1 or -1, okay? So do this important concept of the R will help you to detect your final answer. You got right or got wrong, okay? Our answer should be between the -1 and 1 only, okay? All right, so this is quickly introduce you some important concept. So 12.3 is very important. You have to read carefully, okay? And take notes. And this summary here, positive correlation, slope positive, like the first case here, A, and B is in the middle. That's one is a negative correlation. And the C is zero correlation. It's a horizontal line, right? Then we have coefficient of the determination. So this another question could come to you on the homework, quizzes, or exam time, okay? You have to understand R squared stands for coefficient of determination. And what does this number will tell us here? This number will tell us how many percent, okay, representing the percent of the variation in the dependent variable y that can be explained by our variation change in the x here. Our x is an explanatory variable, right? In algebra, we only call x and y. So the first variable is x independent variable, or you can call explanatory, okay? And the y is the second variable, right? That's what we call dependent variable, because that one is dependent x come in, you get the 1y, right? X equal 1, your y may be equal 2. X equal 2, y may be equal 4, and depend on what number you put in. So that one, usually we use as a predicted value, okay? So coefficient of determination will be on the exam. You should know about this, okay? So I would say this 12.3 is very important, okay? Read it again. And 12.4, testing the significance of the correlation coefficient. To testing the significance of the correlation coefficient is what we required, because if you don't test it, how do you know your straight line is good enough to present prediction for the whole population here, right? Therefore, we need to do check the significance of the correlation coefficient, okay? And if you know how to use this test, okay, linear regret t-test will be easier, because this one will provide p-value, and you can use a p-value. If p-value less than the alpha is we can reject the null hypothesis. And also you have to learn one thing. For the chapter 12, our null hypothesis, we always have to write this way. The null hypothesis, HO, is using the rho equals 0. This symbol, that's one, look like a P. It allows students, when I ask them to do the project, some students just show me the P. This is not the P, okay? This is, we call pronunciation rho, like R-O-U, rho. It's from the Greek. It's the population linear correlation. To present all the population, we use rho. And just for simple only, we use R, okay? So there's a difference here. Just like in our hypothesis testing the mean, we use the S bar for the simple mean. And when we testing the population mean, we have to change to the mu, okay? Same idea. So rho is a population correlation coefficient. First, we have to assume equal 0, okay? There's no relation. Linear correlation is 0. Excuse me. In alternative HA, we always testing, they are not equal 0. You have to put the two-tail test, not equal to. Don't put the greater than 0 or less than 0. That's wrong. You have to use not equal 0, okay? Two-tail test. That's why our critical value for the linear regression test, we have two critical values, plus or minus two numbers, okay? Keep in mind. So you have this part is also important. And this part also remind you when you do the hypothesis testing, you can use a p-value to draw the conclusion, or you can use the method tool, use a table of the critical value. And the critical value, I think I will post that table. There's one table, very easy to use. So when you, I will post it on the, I will post on the Math 96 there, and also post in the our state 1000 site, a table of the critical value, okay? Today I will show you using the p-value first. Then, because the table is easy, just read sample size and go to the right side. You can grab the critical value and just compare. Okay. And the next section is a prediction. So after we done the test, and if your linear regression is significant, then you do prediction using our regression equation. If it's not significant, don't use it, okay? Don't use it for the prediction. We have another way to do it. We have to use the mean of all the y. That's a y bar for the best prediction, other than using some regression equation, which is not significant. And the reason we cannot use some linear regression, because in the 12.3, you can see some example shows the points not close to each other, make the significant linear regression like this example here, okay? Like the second one here, you can see the point is spreading around. So even you find the one straight line go among them, it's not a good representative to do the prediction for some other point because they're far away each other, okay? That's why we need to test the significance first, okay? Before you do the prediction. And the exam question will test your concept about this. So let's go to, I select one questions from your homework of the chapter 12, M, module 12, homework, question 13 as an example, okay? Now I'm going to share the screen with, I need to stop this one and share the screen with our homework assignment as an example. So can you see my homework assignment here?
Yeah.
Okay, thank you, Kiara. This example is from my version of the module 12 homework question 13. And original problem, I think, is they give the 13 data, 13 data, 13 minivans from the Honda Odyssey minivans data there, 13. And I don't want to spend too much time just for input the data, okay? So I cut that table into 1, 2, 3, 4, 5, 6 only. So for you, you might get 13 rows here, but I just use this one as an example. That's why my statement here, I changed. Instead of originally 13, use the Honda minivans data here. I change it in red color as 6 because I only have 1, 2, 3, 4, 5, 6, okay? To save our time. But the way to do the problem is the same, okay? Then look at this. The question give you this real world data, okay? Actually, I prefer to use the real world data because that's more useful. That's what you will encounter one day. That's for your project or for the next class, right? They will use the real data. And this data shows year and make of the car, Honda, and model with the Odyssey minivan. Then mileage and the price. because some students saw the problem like this and got confused. Wow, how can I do correlation? So many data here. Our graphing calculator TI-8384, so far we know only two set. You have input only L1, L2, okay? And the problem also said on the top here that I put here, example from M12 homework question 13. A, you need to compute the correlation between mileage and the price for these minivans. So when the problem give you a lot of data there, it's not all the data you have to use it, okay? You have to read the problem to see what I need to compute here. So correlation that I need to find. So I need to find the R because this is just sample data, not the whole population, right? And what I need to read the data only under mileage and the price. So when you come to the, the given data here, I just look at the mileage and the price, okay? So on your graphing calculator, you can turn on the calculator now and try to follow my instruction here. Let's do together. So after you done this, you can do your own, okay? Your homework exercise, you really need to use your TI-83, 84 to do it. Because a lot of homework, about 10 or 15 questions there, it's always we give you the data in Word, okay? I try to, okay. So I'm going to turn on the calculator now. And first thing you do, you need to press on Stat, Edit, okay? So I hit on my calculator, Stat, and you will see the screen pop up, Edit, number 1, okay? So it's just to confirm. This is like a computer, okay? Mini computer, your calculator. So just hit the Enter, okay? So when you see Edit pop out here, I will hit enter. Okay. Look like it doesn't allow me to type anymore. After the edit, okay, maybe I do. After the edit, you need to hit the enter, okay? Enter. Just hit enter. On your calculator, just hit the button enter, okay? I come to here. Control F should be here. Control P, enter, okay? And this is a step 2. Step 1 is yeah, they're repeating again. Let me eliminate this one. Okay. So press the Stat, Edit, Enter. Then you will see the screen pop out L1, okay, and L2. So under the L1, L2, you just type in, okay, type in the data. So under the L1, I will type in the mileage, 20, 21, 33, and 41. And what is this here? I don't need this anymore. Get out here. Yeah, okay. So now you can see the data. 20, 21, 33, 41, and 43. Down arrow key to 67. So make sure under L1 you have 1, 2, 3, 4, 5, 6 data, right? Then move to the right side under the L2. You will type in the price. So price is a bigger number, 269.00. Okay. Enter. Wow. What's happened here? Stat. I have to redo again. So type of stat, edit. Okay, I already input the mileage. Now price doesn't allow me. 269.00. Okay, enter. every time I have to remember, hit the enter. Then 23,000. Enter. Okay. And 175, 30, no, 20 only. Oh, 23,000. Yeah, okay, it's 30. But 17,500, enter. Then the other one is 18,999, enter. And the next one, 172,000, enter. And the last one, 189,995, enter. Okay. So everybody try to follow the instruction, enter all the data, the mileage and the price under your calculator, edit under L1 and L2. Okay. After you done that, then you can click. You press on step 2. You press on stat again, statistic, and move your cursor right hand. Go to the right side to the test. Then select the bottom one. Not really the last one, but at the bottom here, you will see linear regression t-test. That's the right one. When you see that one, you just hit the enter. Okay, hit the enter again to confirm. That's the function you will need to use it. Then your screen will pop out. X list is L1 they read from our input, and the Y list will show L2. So that's good. Then you will see frequency 1, don't touch that. That's the part of the programming, okay? And go to the next one, okay. X this don't touch, Y this don't touch, frequency 1 don't touch. But when you see beta and roll, right? Beta look like a B, right? My keyboard doesn't have beta, so I just type B. And the roll, another roll, is like the P, but it's not P, it's roll, okay? It's from the Greek. Then you need to select, this is the important part. You have to select not equal to, okay? Not equal to, so I put a slash over, okay? So this one is the right choice, not equal to. You have to choose a two-tailed test. Because we don't know. It will be greater than 0 or this, or positive or negative. We don't know. Okay. The price with the mileage is go positive direction or the negative direction. We don't know. So that's why we need to use a two-tailed test. Okay. Make a note yourself. Always consider linear regression test. It's a two-tailed T, and we have to use a t-test. 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 Okay. Then after you done this one, you can see regression equation. You can type that one there to show you equation, but I will say just continue, go to calculate. And we have something more important to go calculate. Okay. I will go to calculate and hit the enter. Okay. Calculate and hit enter. You will see the bunch of the information will pop on your screen. Okay. And this is very important now. This to try to help you without using those algebra I presented earlier on the section 12.3. Those big formula there. You don't need to go through that complicated formula there. You will just write your equation y, but if you write your project, you better write y hat, okay? Y hat is estimated y equal a plus bx. So you need to put the a in. And the a, you just look at your screen. What is the a? And my screen shows some number very big here. Let's check with you. I got the 255.81.63.039. That's from my calculator. Did you get the same thing? Double check. That's the A, okay. But the problem said we should round it to 3 decimal, so I'm going to cut this unnecessary decimal. The problem said we should just leave your answer with a 0.001. That means 3 decimal. So I have 3 decimal, 0.630, okay. That's for the y-intercept. And B, okay, B, I'm going to replace my equation here with a B. And this B shows is a negative for my calculator. So I just need to put the negative and copy that the number from the calculator, negative 137.3145. But the problem say only 3 decimal we care. So you just have to do the rounding from this fourth decimal. Since the fourth decimal is a 5, so you need to go up as 1 unit, right? So I will round up as 1 unit, 18 to the 4 become the 5. So that's the final answer you should have, okay? And the screen shows a lot of other information. When we come to the time we need more, we come back here. And no, we need more. I need to show you more. So just use the down arrow key on your calculator and move downward. You will see R square. You will see the X first. And that X you don't need it now. That's for the sum arrow, like a standard arrow, something. What we need now is R square. The coefficient of the determination. Remember that R square? So I will grab this information of the R square, okay? R square equal 0 point. I like to put a 0 in the front. So 0 point, and copy that the point 398, okay? And I round it to 3 decimal as well. And the other information is R. That's the simple linear correlation coefficient. The sample data we use here from the 6th set of the data we have came out negative 0.6309. So I'm going to round it to 3 decimal, and as a 3 decimal should have been negative 0.631, right? That's what we need, 3 decimal. So that shows the mileage with the price is not a positive correlation. Actually, it's a negative. That means the one runs more mileage doesn't mean that one is more expensive. Okay. Usually, smaller car actually less. Smaller car can run more mileage, but the price is cheaper, right? It's a different direction. That's why it came out the negative. So negative 0.631. And that R square, what did R square try to tell us here? Okay, that's trying to tell us 39.8%, okay, of variation between the Y and X to set up between the price and our mileage, right? And the difference of the mileage here to describe what will happen to the price here. Their variation, our linear regression, only covers 39.8%. They are not really follow a straight line up. Okay, so that means the dealership they determine that the price, right? It's not based on the mileage here. Okay, and we know some bigger car actually mileage is less than the smaller car. We know that a smaller car usually is cheaper than the bigger car, that luxury car, right? So makes sense. So 39.8% of the variation have been explained by our regression. by the regression. By our linear regression, actually straight line related linear regression. Or you can describe in more saying that by the variation of the mileage, um, by the variation of the mileage, it causes our price differently. Okay, what kind of variation between the price and mileage here? How many percent have been captured, explained by our linear regression line there? Only 39.8%. Okay. So linear regression is not strong here, we can see. But from the R, we can see it's kind of 0.631. It's a fair linear regression only, okay? It's not a strong. The strong one should be close to the -1, okay? -1 is a perfect. All the points on the line going up. That means if mileage can run more, the price is more expensive. But according to our research study on this Honda data is not, okay? And the reality is not, because we know, I don't use the Honda, but I used the Toyota before. I know my first car was Toyota Corona, I think it's Corona, that small car, the smallest one of the Toyota. That's my first car. I remember I only paid $5,000 only. That's my first car. And that car is small, but the mileage is a lot, okay, running more, I think. Especially now, they improved a lot, okay. And you compare to the luxury car, the Toyota, this is single of what? Well, now they make that the Lexus, right? That is the upgrade of the Toyota. That is expensive, okay? You buy that 400 X series or something. That's I think the 80,000 or some 70,000 there. So, but that one doesn't mean the mileage is better than my Corona at that time, okay? So that's why it shows this kind of result here, okay? So I hope this example will show you some idea what you're going to do in chapter 12, okay? And of course, you need to read the section that will give you more examples and more explanation there. One more thing before we leave here, I'd like to do something more because this is related to our prediction. The prediction is, for example, someone asks you, okay, how about my Honda can run 25 mileage is 25. Can you predict the price for me? Okay. So I will say, depend. I have to check. This R is significant or not. Okay. I have to check. Okay. So this is talking about the prediction. The item C. The three things you need to know, okay, for the chapter 12. A, you need to compute the correlation to find out the linear correlation R, okay. B, you need to determine that the equation, what's the equation of the regression, the y equal A plus BS, that one. And the C, some problem will ask you to do prediction, okay. Predict something we don't know. And because look at that mileage here, we have 20 mile, 21, 33, 41, 43, 67, something like that. But if someone say, my car can run 25, okay, I maintain it at 25. Can you predict the price for me? You have to say, I have to check, okay? So you need to check the significance of the R, okay? The linear correlation coefficient, okay? And how can I check? We have two ways. The book mentioned that, right? P-value or use this, okay? Or use critical value from the table, okay? But today, since we are using the TI 8384, after the test, they have the p-value there as well. Let me see, go back to do the test. Yeah, you should see the p-value, okay? And I check your homework exercise. Some problem, I think one problem asks you to find out the test statistic. So test statistic is right on your screen there. t equal negative 1.6265 is there, okay? And just round to 3 decimal because our traditional way, our t critical value and the t distribution, they always round out to 3 decimal. That's why we kind of follow that. You can round to negative 1.627 to enter the answer if the question asks you, okay? So this is the one we call test statistic. No X behind, okay? This one to show our evidence, how far away from the center, how far away from our null hypothesis. And remember, our null hypothesis is we assume it's zero, non-linear, okay? But here shows we have some distance here is about negative 1.627 away from the zero there. So is this significant enough to present the whole population, our R, our equation of the regression? Then you check the p-value, okay? So the p-value is presented by your calculator as a small p, okay? They usually just use a small p. And the small p is 0.17916. Okay, 1/6. Usually p-value probability, we tend to go to 4 decimal for hypothesis testing. So I will go to 5 decimal, right? 5 decimal. Then round from here become the 0.1792. 2, because that 6 is greater than 5. So p-value, if we got the p-value, that's good. You can use the p-value compared to our alpha significance level, okay? Remember the rule, okay? The rule is this. If p-value is less than the alpha, less than significance level, then reject. No hypothesis. We always apply this, okay? Since chapter 9, right? We applied it. Chapter 9. If you do read the chapter 10, also apply this. Chapter 11, chapter 12, all chapter 13, even the next chapter. We always follow the same rule. If p-value is smaller than alpha, then you can reject the null hypothesis, okay? So we compare our alpha. Usually, probably give you some alpha there. If they don't give to you, just compare to 0.05. That's a commonly we use in the real world, okay? So you can compare to 0.05, the common use, the significance level. So you can see this is not less than, right? This is greater than. So I have to change. 0.1792 p-value is greater than the alpha. Alpha is only 0.05, right? You got to be smaller than that number to reject, but we are not. You can see p-value for this case here is greater than 0.05. So we fail to, or we do not, okay, reject the null hypothesis. We cannot reject, okay? So if we do not reject, that shows our R, that R, the linear regression coefficient, we collect from the 6 sample data only, is not significantly enough to present the whole population here. So we cannot use that regression equation that we got here. I think I wrote here earlier. Yeah, here. We cannot use that one for prediction. Okay, you cannot, because this one is the equation, right? This is a regression equation. The one you put the random number here, that's the equation. Okay. I use the mouse to write, so ugly equation. Okay. So this is the linear regression equation, and we cannot use this one for prediction. If your p-value is less than 0.05, yes, we can use this equation to plug in what is the x they want you to find. Oh, my linear regression, I forgot to write something. That's the common mistake from the student too, and my mistake too. Here, you had add on x behind, okay? No x, this is not the equation. I just solved now. Okay. Here, you need to put the x. Doesn't allow me to do anything. I want to edit. I need to put the x here. X. No. Here. Okay, you edit yourself. We should have x here. Okay. I'm going to use the black pen. Okay. We should have x here. No x here is not the equation. Okay. Y equal 25581 point something minus 137.31 x. That's the equation. Just like in algebra class, right? We always have y equal and y-intercept and plus some number, but the slope attached with the variable x. Okay? You got to have x here. Okay? No x is not equation. So good, we catch that. Then this problem is you cannot use this one to do the prediction, okay? And you will ask me, how about now? If we cannot use this equation is not significant, how can we do now for prediction? Well, in statistics, if we fail to reject that null hypothesis that shows our linear regression is not significant, okay? Because it's it cannot represent the whole population. Didn't pass the test here. Okay. Therefore, you have to use. I'm going to. This writing is so ugly. Let me erase this and click on some function to write. Okay. I will use this one to write. So, if correlation is not significant, right? Correlation is not if the R is not, no, not the R, if linear correlation is not significant. Just like this example, we didn't pass the test, okay? We cannot reject that no equals 0 because we only, our R is not strong enough, okay? And p-value got is smaller, but p-value is not small. So that means that it's not significant. So if correlation is not significant, we cannot use regression equation for prediction. It's very important, okay? So we must use Y bar for prediction. We must use a Y bar. So remember what's the Y bar? It's a Y, right? Y, and with a bar on the top, okay? Maybe let me use this one. Oh, you can put a bar on the top, okay? Like a X bar, okay? Y bar. You have to use a Y bar. And what is the Y bar? It's the average of the Y. That's what we call Y bar, right? So average of the Y variable we have. So you just have to use all these variable under the price here, the 6, add up and divide by 6. So we can tell the people, this just estimated, okay? Because the regression equation is not significant here. We only use the 6 pair of the data. And we did the hypothesis testing, shows that it's not significant enough to predict using the regression equation here. Okay, so remember this, what I wrote for you, because that will be part of the test here, that you will find out that if not significant, what should we do? Okay, remember, you use the white bar, okay? This is important. When it is not significant. Okay, so I think today I mentioned that everything is important for you. So next week, Thanksgiving week, you will have more holidays to study, right? All right, already 6:09, so I will see you not the next week. So I have to say a happy Thanksgiving, right? It's Wednesday we have class. I think we still have class. Okay. I confused with another class. Yeah. Another class is Thursday. So Thursday, no class. But the we is on-site class. But this is online class. So we still have class. So I will still see you on Wednesday next week. And hopefully you finish your chapter 12. And if you have any question, you can bring up to ask me. Okay. And also, next week I will start talking about chapter 13, okay, to help you head up for something you needed to know. Okay, so bye bye everybody.
Bye. Thank you.
Bye.
You're
Thank you.
welcome. Bye bye everyone.